All right, so this one comes under sequence. It says a geometric series can be expressed by y over x plus y squared over x cubed plus y to the third over x to the fifth, and so on. Prove. So now they're saying, hey, can you prove this? That the sum to infinity is that. So in other words, they don't want a value for the sum to infinity because you can't get a value because we're not having numbers there. We're having expressions and ideas. So they are saying, hey, prove that the sum to infinity would have given us that. All right. Basically, what you want to do in order to do sum to infinity, one needs to remember what the formula is for sum to infinity. So I could just put the formula sum to infinity. So if we have S, basically that's what we have, right? And we set it like that. And basically there are little conditions that, so we're talking about when R is less than 1. Let's throw this in. So in other words then, we have some of the pi already because we have A. A is that first term, understand? So we have that part to work out the sum to infinity. So you could see that this is going to definitely just be how well you can use your algebra, right? What we want to find is R, all right? So we need to find R, so we could substitute and then we start working stuff. So in order to find R, right, you could list out some stuff. The first term, as you could see, is y over x. Term 2, as you could see, is y squared over x to the third, and you could write the next one. Term 3 is y to the third over x to the fifth. So in so doing, what we're seeing here is that you can utilize any two of these. All right. Now remember, you're trying to find the ratio, which is R. So it's going to be either you have term 3 divided by term 2, which is the same thing as saying term 2 divided by term 1. So both of those would give us R. All right. So you want to just work out anyone you want just to find R to be substituted, and then the work goes on. So the intention is to find R. So let us set it up to find R. Y, where could I put this? All right, right here. Y square x to the third. So that's term 2. And I'm going to divide. So I'm going to use it this way. Why? Because I see that we have another fraction coming. So instead of having fraction over fraction, I'm using this division because I know I'm going to reciprocate and do canceling. So we're going to divide this by y over x. But you could see, pushing this further, you'll keep this one at the front ordinarily, just like regular fraction, and then you multiply by that. Now we're going to cancel things that can be canceled. So check it out. We're seeing here that this y will cancel one of that, and this x will cancel one of that, leaving 2. So R is basically y over x squared. I'm going to take this. I'm going to come to the left of the screen. Now, we're suggesting that the sum to infinity is going to be A, which is the first term. As you could see, it's going to be y over x. And you want to divide that by 1 minus R, which is y over x squared. So right there, this is our setup. This is going to set the tone for what we're going to do. So from this, what you want to do now is I would work out this part to give me a single fraction under there. I would want to have a single fraction under there to use it. All right. So I could focus on that part. And when we're done, we divide it by this piece. All right. So you could isolate it. So let us say that we want to isolate this part. So 1 over 1 minus y over x squared. So if you do some quick fractions here, let me put it to the side. Let us say the denominator would have been x squared, the LCM. 1 into x squared is x squared. So you get x squared times 1. Regular fraction we're doing, you get your x squared. X squared into itself is 1 times y gives us minus y. That is what we have coming from underneath, right? So underneath, we have that coming out. So what I was suggesting now is, let us take a look. what we're working out is y over x. And instead of using this line now, I'm going to say divide, right? And then I'm not going to do division because we know what to do. So we're going to multiply by the reciprocation. So I'm going to put the x squared at the top, and then I'm going to have the x squared minus y right there. So you're seeing where we're working out stuff. Remember though, the goal in mind. You have to remember the goal that we have in mind. So let us see. Currently, I'm seeing a little canceling could take place, right? When you really look here, we can't touch this. That's a binomial. But definitely I could touch this and that. So technically now I'm seeing where I'm getting the xy on top of x squared minus that. Now, if I look at this, I'm seeing the answer right now. If I look back at this, we're done, because when you really understand what numbers are and what expressions are, then this is saying that the xy could be pulled off, and it really means that you're left with 1 over x squared minus that. I'm just showing you that this that we have at the top here is the same thing as representing it this way. Why am I doing that? Because I'm zooming in and getting this part out so I could feel secure to say, oh yeah, watch this. So from here now, we are able to say the xy is there, and then this is multiplied by x squared minus 1 minus y and to the negative 1. How did you get that? Inverse. The inverse simply means negative 1. So now you have, so it's all about, can you manipulate the thing to suit what they had asked?